Hey everybody, today I will be going over Learning Target 5, which relates to limits. More specifically, evaluating limits both graphically and analytically. So starting off with part A, we're given a graph of the function f and we need to state the value of each quantity. This involves both limits and function values. So starting off, we're asked to find f of -1, which is the corresponding value when x is equal to -1. And that occurs right here. But as we can see, there's a hole there, which is a discontinuity. And at a discontinuity, the function does not exist. So we can write d and e. But then next, we're asked to find a limit as x approaches -1. And for a limit to exist, it means that when you come from the left and from the right, if that approaches the same value, then you have a limit that exists. In this case, from the left and the right, we're approaching a y value of -2. And it's okay that there's a hole there. It's okay that there's a discontinuity. Even at that hole there, we can still evaluate the limit because of the reason that we can approach from both sides. Now we're looking at the limit as x approaches 0 from the left. That's what that minus sign means right there. This means from the left. It's approaching 0 from the left. And this evaluates to -1. Since we're coming from just one side, that limit is allowed to exist. Next, it's asking us to find f of 2. We go to 2 right here, and that corresponds to this point right there with a y value of 1. Even though the limit might not exist there because it's coming from two different ends, that's okay because we have our value defined there with that closed eye. I think I spoiled number 6. We'll go to number 6 now. It asks is the limit, what does the limit equal as x approaches 2? Since we're coming from the left here, and that approaches a value of 1, and from the right here, that goes to infinity, the limit does not exist because it approaches two different values. But if we approach 2 from the left, this approaches that point again, which is equal to 1. Now we're going to compute some of these limits analytically. So first, we're given that the limit approaches -2 from the right. So we plug in -2 first of all. We're going to get -7 over 0. And we don't really want this because this 0 in the denominator means that it's undefined. So we need to figure out how we can evaluate this in a smart manner. So let's pretend that we're approaching -1.9 repeating. I'll write that. -1.9 repeating over -1.9 repeating. And the reason I'm writing that is because that's pretty much what the limit is saying. We're approaching -2 on some number line. Here's -2. We're approaching from the right. So at a super duper duper close point, we have -1.9 repeating. That just gives you an idea. So this will pretty much become -7, almost. Not exactly because of that 9 and repeating, but I'm just writing that for simplification purposes. And then this bottom will be really, really close to 0, but not quite 0. In fact, it'll be some positive 0.00001 value. And that is a lot more zeros there. This is just equal to -infinity because this denominator right here is infinitesimally small. It's just so ridiculously small. And that numerator has a value of -7. So negative over a positive is just equal to a negative. So -infinity. For this next one, this one is pretty routine. We can just go ahead and plug in our x value of 1. and we get 5 over 10, which is equal to 1/2. No tricks with that one was just very routine. This next one though, I'm going to go ahead and just show you what happens if I plug in 4 immediately. We'll have 4 squared minus 5 times 4 plus 4 over 4 squared minus 16. And this is equal to 0 over 0, which like our first limit that we solved, we don't really want to deal with this because it's undefined. So we need to think of another way that we could solve this. When you see a polynomial over a polynomial, and you've plugged in your values and you get 0 over 0, your next thought should be to factor both the numerator and the denominator. And this one ends up factoring to x minus 4 times x minus 1 over x plus 4 times x minus 4. And we have a couple similar terms here, x minus 4. Those just cancel out, or they divide out. So we are left with the limit as x approaches 4 of x minus 1 over x plus 4. And now we can just plug in 4 for x. That's going to be equal to 3/8. And there's our value. So just to reiterate, when you have a polynomial over a polynomial, and it's valuing to 0 over 0, or at least just the denominator is equal to 0, try factoring it out and see what happens. Finally, we're left with one last limit, and this limit definitely looks a little bit wonky. So we're going to need to use a strategy called multiplying by a conjugate here. And I'll get into that in a second, but I'll just show you what it looks like first. We can say that the limit as x approaches 25 of the square root of x minus 5 over x minus 25. And then what we're going to do is we're going to multiply by its conjugate. Its conjugate is going to be x plus 5 over the square root of x plus 5 over the square root of x plus 5. And the reason we can do this is because the square root of x plus 5 or the square root of x plus 5 on its own, that's just equal to 1. So we're left with the same thing originally. This just helps us solve it algebraically. But we're going to leave it there for now. So now what I need to do is just multiply this out and get it into a cleaner form. I'm going to do that on the side here. I'm going to show you a trick of what we can do eventually. So we're going to have, starting in the numerator, the square root of x minus 5 times the square root of x plus 5. So now we can FOIL this out. And we're going to get square root of x times the square root of x is just x. Square root of x times 5 is 5 times the square root of x. Negative 5 times the square root of x is negative 5 square root of x. And negative 5 times 5 is negative 25. So these two terms here will cancel out, and we're just left with x minus 25. So just looking at these two factors here originally, you may or may not see a trend. And this trend is whenever you multiply some factor by its conjugate. So let's just say that we have square root of x minus c times the square root of x plus c, because the square root of x plus c is its conjugate. We're going to get x minus c squared. For any combination, x could be, or c could be 6 or 10 or 100 or 1,000. This little formula here is always going to work for conjugates. Remember this one. If you have to, you can always just solve it out like I did here. It's just a quick little FOIL method. It doesn't take too long, but knowing the rules of the conjugate can save you a little bit of time. So I'm going to go back over here to our limit. We have the limit as x approaches 25. Using our rule, x minus c squared, we will have x minus 5 squared, so x minus 25. And the bottom, we'll just keep in terms for now. multiplied by each other. Just like the last last limit we evaluated, you may see a couple similar terms here, x minus 25. So those can just divide out. Now we are left with the limit as x approaches 25 of 1 over the square root of x plus 5. Plugging in 25, the square root of that is 5. So we get a value of 1/10. I hope this all makes good sense to everybody. If you have any more confusion or questions, just stop by office hours and we'll try to help you out.